Hello, you absolute legends. Imagine we have a little pile of dust in our weigh boat that is 2.40 grams, and it is magnesium sulfate with 4 hydrated waters around it. This models right here is kind of meant to represent kind of just like a picture of what that looks like here. We have the MgSO4, the Mg, and then the 4 waters around it right there. Kind of just like an image, an atomic vision image of what's going on there. Our first question is asking about how many moles of this stuff do we have here? So we're told the grams, we're asked to calculate the moles. Bada bing, the periodic table, the elemental masses contain the grams per mole of all of these things. So let's add them all up to find out how many moles. We get the molecular weight of magnesium sulfate with 4 waters on there. So I'm going to round these a little bit here. (202.3 grams per mole). So when everything is added up right there, 202.3 grams per mole is the molecular weight of this stuff here. And hint, hint, just remember we did that by adding everything together. So you have 2.4 grams of it. We want to find out how many moles of it is. We want to set up just a baby scaffold. It's just going to be a little tiny one. 2.40 grams, 202.3 grams per mole. Units cancel. And this will be the moles of MgSO4 with 4 waters. .01. Okay, that's not a new problem right there. That's not a new problem. We've done it in the past, but this one has a twist right here. Okay, what if we just want to know the moles of pure MgSO4 that are present right there? So consider the following. Like, this is how you buy the compound, magnesium sulfate, and it comes with 4 waters. But you could heat this compound and get rid of the waters, and that's one way to work with it right there. How many moles of magnesium sulfate would remain if you heated off all the waters right there? We can calculate that with the same idea of how we got this sum right here. Okay, so for all of these things together, we added them together to find out the total weight of 202.3. That's all of them added together. Let's separate them. We have the 4 waters up here, and now we have the magnesium sulfate. If we separate these, what do they add up to? Well, the 4 waters add up to 72 grams per mole. And the magnesium sulfate adds up to 120.3 grams per mole. So note that the parts, why doesn't that add up to the sum? This number was off. Hope you're following along. I made an initial mistake down here. This is 192 grams per mole. Math I did was correct, but it's not. So the answer to the first problem excuse me, 2.4 divided by 192. 0, actually, it doesn't really change the answer. 0.13 moles. Okay, now back up to here. The parts add up to the sum. The parts of water add up with the parts of sulfate and magnesium to get the whole shebang right there. Nothing crazy right there. But from knowing these individual parts, we can get a ratio. How many of the 0.013 moles, how much of it is just magnesium sulfate? We can just set that up with a little ratio right here. 120.3 divided by 192, the part and the whole. Their units are all going to cancel out, times 100%. So that would give us a percentage of how much is magnesium sulfate. (62.5%) is magnesium sulfate. So if this is our total moles of everybody together, the sulfate in the waters, we take this number, multiply it by the proportion 0.625. There we go. So 0.008 moles is dry, clean MgSO4 with the waters removed if you cook. I hope this helps. Thank you.